then you will get 126 times the diameter. So this much length you have to give if the Reynolds number is 2100. So this much. These two are low Reynolds numbers. Low Reynolds numbers. Low Reynolds number. These two. So that the meaning is that entrance length should be minimum of 126 times the diameter. Then only the flow will become fully developed. And for higher Reynolds number, for example, some Reynolds number greater than 4000 or equal to 4000, then what is the expression? So we have to use the second expression. Le by d approximately equal to 1.6 into Re raised to 1 by 4. You can substitute this Red into, that means Le by d is equal to 1.6 into 4000 all raised to 1 by 4. So if you solve it, you will get this expression, 13 times d, that you will get it. But the thing you have to think is that whether what is the difference in these two cases? Even for higher Reynolds number, it is becoming 16d only. 10 for 6, 10 for 7, it is becoming maximum of 19d. But here for laminar, it came, see, laminar flow, the entrance length is very high, 126 times d. And here for even though for 10 to the power 7, entrance length is 90 times d only. So what is the difference? What is it? Uh, the thing which makes the entrance length very less for turbulent flow. That uh, for to explain that, we need to understand two concepts. One is one is viscous transport, and second one is um, convective convective transport of momentum. Okay, so that um we can discuss in the next class. These two things we will discuss in the next class. Okay, so viscous transport and convective transport. So before going, Re is nothing but inertia force by viscous. This we have to keep in mind. Re, the expression is that rho v d by mu. That also you have to keep in mind. But so this is Re. Re is equal to inertia force by viscous force. Okay, so Re is equal to inertia force by viscous force. The inertia force proves Re becomes large. That means um, inertia force is nothing but the flow. That is, there comes the convective convective transport. And if viscous force dominates, Re reduces. There comes the viscous transport. Okay. So according to the dominant force, if inertia force is more dominant, then convective transport will become prominent. And if the viscous force is dominant, means viscous transport will happen. So this is some relation, and we will discuss further in the next class. So I think for today's session we can end. And if you have some doubts in whatever things we discussed, you can ask someone or some type of any. So did you understand the Poisson flow and Cauchy flow? Uh,
No,
Ah,
no.
yes, sir.
okay, fine. Some of the major difference between the Cauchy flow and Poisson flow. Can anyone tell what exactly the Cauchy flow, what exactly the Poisson flow?
Move, sir. One of the plates move in Cauty flow.
Yeah, yeah, yes, yes. Yeah, one plate fixed, one plate moving. The other thing, both plate fixed. And the profile. If you are saying in terms of profile, then Poisson flow is parabolic, and Cauchy flow is linear. And another difference is that flow is driven just because of pressure difference in Poisson flow, and Cauchy flow, the flow is because of the movement of the plate. And the expressions you have to by heart, and further discussions we can make in the next class.